Good day everyone, my name is Glyza Serrano and welcome to my tutorial on one of the most efficient string searching techniques used in computer science, the RABIN-KARP algorithm. String searching is an essential problem in computer science, and the RABIN-KARP algorithm is a clever solution that combines the power of hashing and pattern matching to search for substrings within a given text. So by the end of this tutorial, you'll understand how the RABIN-KARP algorithm works. It is a step-by-step process implementations and when to use it for optimal results. Now, let's start writing. First, what is the RABIN-KARP algorithm? The RABIN-KARP algorithm is a string matching technique that uses a hashing mechanism to find a pattern in a text. It is efficient for finding multiple pattern matches in a single task, making it great for applications like plagiarism or searching DNA sequences. RABIN-KARP algorithm, how does it work? First is hash calculations. Compute the hash value of the pattern and compare it with the hash values of substrings in the text. Second is sliding window approach. As you slide the pattern over the text, recompute the hash value efficiently instead of recalculating them from scratch. Thirdly is verifications. If a hash value matches characters to avoid hash collisions. A hash collision occurs when two different inputs produce the same hash value. So we will discuss that later. And these are the step-by-step explanations. So first is initialize the variables. Secondly is we will compare the hash value. And thirdly is repeat until completions. So let's start.
RABIN-KARP algorithm. When the text is given and the pattern is given, we need to find out if the pattern is present in the text. And along this tutorial, we will also try the worst case RABIN-KARP algorithm. But before that, let's start with this example. We can see that the CDA is existing in the text, but we need to check. When we check, we don't compare alphabets or subsequence numbers one by one. We will convert it to a numeric value. Let's start, which is A is 1, B is 2, C is 3, D is 4, and E is 5. So I will assign 5 values. This is more recommendable than ASCII codes when you are assigning more bigger numbers. Using these numeric value codes, we were trying to test if the pattern is existing in the text. We will use these values. C is 3, D is 4, and A is 1. Add these values and we will get 8. So the 8 is called the hash code. So now let's start with our first hash. We will take the 3 letters. A is 1, A is 1, and B is 2. So we get it in our numeric value. So the result is 4. So now let's see it is exist in our pattern. So 4 is not matched with 8. So it says that the text is not matched in our pattern. So second hash. A, B, C. So now let's put numeric value. And the result of this is 7. So now let's compare, and again not match with our pattern. So let's go to our third hashing. B, C, D. So now let's put again the numeric value 2, 3, and 4. So the result of this is 9. So let's compare again. So not much. So we will go to our fourth hashing. C, D, and A. So now let's put the numeric value. And after that, let's calculate again. So the result is 8. So now let's compare. So it says that it matched. And also, the pattern within in the text is matches. So now let's put the result. So it says that it found in index 4 to 6. So now let's put the indexes. So note, every starting with the strings, it have an indexes. So it's starting from 1 or to 6. So now let's go to our second example. Let's put the numeric value 1 and 3. So the result is 7. So now our hash function is 7. Now let's put the index. Now let's start our first hashing. Now let's put the A and C for our first hashing. So now let's put the numeric value 1. A is 1 and C is 3. So now the result is 5. So let's compare. So not much because the result of the hash function is 7 and the first hash is the result is 5. So now let's go to our second hashing. So our second hashing is A, C, and A. So but we will use the simple method to calculate the result of our second hashing. So the method is we will put the result of the current and let's plus the numeric value of A, which is 1. So the result of this is 5. So now let's compare. So the result is not much because our hash function is 7 and again and our result of our second hashing is 5. So now let's go to our third hash. So our third hash is A, and C. So now let's use the simple method to calculate the result. So 5 minus 1 equals 4. So the numeric value of C is 3, so plus 3. So the result is 7. So let's compare. So the result is yes, match. So because it is match, we will confirm it and print or getting the result. So now it says that the CAC is found at index 3 to 5. Let's go to our third example. So we will use subsequence or we'll use numbers to represent the RABIN KARP. We will do is we will not assign. So instead, we will calculate these two numbers and the result of this is we call the hash functions. So the result of this is 68. Let's go to our first hashing, or it's called window 1. So we have 12 and 23. So now we will plus this 2. So the result is 35. So now let's compare it. So it's said not much because our hash function is 68. So we will use again the simple method to calculate or to have the result of these numbers. So now let's put the 35 and then minus it to 12. The 12 is the index found in the index arrow. So we will plus the 45, which is our second hashing. So now, the result of this is 68. So now, it says that it matched. So, we will check the pattern. So, it said that the pattern is found it in our index 1 and index 2. So, 68 is found. So it said that 23 and 45 is found, but we will complete this hashing because we can see that the pattern is existing again. So now let's go, or let's start our window 3. So it is saying we will use the simplest way to solve or to have the result. So now it says that the 68 is matched with our hash function, so we will call it the hash collisions. It has the same result but different patterns. So now, we will go to our window 4. So this 68 is called hash collisions. So we will proceed to our window 4, which is 23 and 45. The result of this window 4 is 68. So let's confirm it. So it says that 68 is found at pattern or index 3 and 4. So the result of this is 2 because in our second window we found the 68. In our window 4 also we'll found the 68. So now let's go to our window 5. Let's check if the result is 68. So the result is 90 and not matched with our hash function. So let's confirm again the result. So found at index 1 and 2, and our second result is found at index 3 and 4.
That's the RABIN KARP algorithm in action. It is a powerful tool in string matchings, especially when you need to search for multiple patterns in large data set. If you found this video helpful, don't forget to like, comment, subscribe. I'd love to hear your thoughts or questions in the comments below. Thanks for watching!